So next question is three machines and for example three machines and six jobs. How to calculate the make span time? How to calculate the optimal sequence? So as we have solved already two machines n jobs, so now we have to complete. If we complete this, then we will be confident that we can solve any number of machines problem. In exam, they may give maximum three machines. So that's why I am doing one problem from three machines also. First, because this war is entirely problems. Mostly theory questions will be very less. So again, three machines and n jobs. So in this, first we need to convert. We need to convert. Maximum of that. Right. Just maximum of Ti2, minimum of Ti1. Okay. First check necessary conditions. Necessary conditions. Maximum, sorry, minimum processing time in machine 1 is greater than or equal to maximum processing time in machine 2. Maximum processing time of maximum processing time of any job in machine 2, or we have any of the condition minimum processing time in machine 3 greater than or equal to maximum processing time on machine 2. So minimum processing time on machine 1 is 1, greater than or equal to maximum processing time on machine 2 is 6. Another one here is 6 greater than or equal to 6. So one out of these two conditions, one condition has to satisfy. This is not satisfied, but this is satisfied. So one condition is satisfied, which tells us to go ahead in the next steps. So now we need to calculate the hypothetical machines processing time. So processing time for hypothetical machines. R and S. So job J1, J2, J3, J4, J5, J6. Machining time of R MR equal to M1 plus M2. MS equal to M2 plus M3. 12, 10, 7, 10, 11, 13, 7, 12. So add the value accordingly. Formula 3, 8, 3, 9. So this is the final table which we got after converting this into two machines n jobs form. Now it is in the form of two machines n jobs. So then what you need to do? Calculate optimal sequence. So for optimal sequence, first you need to find out of the two machines which machine is having lowest processing time. If you look at that, J5 and J6 on machine R is having lowest processing time, right? So the lowest processing time is on machine 1, keep it on first. So J5 I am giving. Why we can keep J6 also? Why I kept J5 is because machine S processing time on J5 is less than the machine S processing time on J6. Even if you keep J6 also, it gives same answer. So next minimum is 7, which is on J2 and J4. So again we can keep J2 and J4. Next minimum is 8, which is in J5. So you have to write that is in machine 2 of J5, you have to keep on the last. So remaining is J1. So the sequence, we got the sequence J5, J6, J2, J4. What else is missing? Something is missing. Okay, sorry. This one is J5 we have already used. We need to take J1 minimum. Here it is J3. Because J5 already we assigned. Again, we don't need to repeatedly assign. Only once we need to assign this optimal sequence. J5, J6 are assigned. J2, J4 also assigned. After 3 and cancelling next 7, then next is 10. So this is in J1, machine 1 of J1. So optimal sequence also, I got the optimal sequence, and now I have to calculate the idle time or max span time of the machine. So first, sorry. So why we need to convert the n machines into n jobs to two machines n jobs? The objective is to find out the sequence first. So we got the sequence, then we don't need about the two machines n jobs. We can take again initial one. So M1. So machine 1. Look at the machine 1 processing times in and out. I think if you need it, I will write the machine 1 processing time, then it will be clear for you to understand. Processing time of machine 1, the I is processing time of machine 2, next is machine 3. So for J5, 2 1 7, J6 1 2 7. This is in the given data. Machine 2 3 4 6. Machine J4 4 3 9. J3 5 6 7. J1 10 2 8. This is the data we have. So now we need to calculate the in and out time on machine 1 of each job. So first machine, it came at started with any machine. First machine is 0 only. 0 plus 2 2. 2 plus it starts again. Second job will that job 6 will start at second after second. So 2 plus 1 3. 3 plus 3 6. 6 plus 4 10. 10 plus 5 15. 15 plus 10 25. Why the I am adding each job processing time. So it started at 0 and the processing time of machine job 5 is 2 hours. 0 plus 2 2. So next after completion of job 5, then job 3 will start processing. Job 3 requires 1 hour. So both jobs will be completed by end of 3 hours. That is a here process. Machine 2, in and out. So starting time is 2 hours because job 5 will be over in machine 1 by 2 hours. So we need to wait to the machine will be idle first 2 hours. So processing time in machine 2 is 1 hour, so 3 hours. So 3 hours this machine 1 also the job 6 will be over, so it will come on the to machine 2. So but by 5 hour, by the end of the fifth hour, job 6 and machine 2 will be over, but job 2 is not yet reached. So job machine 2 has to be idle for 1 hour to get the jobs 2 from machines 1, which will release at the end of sixth hour. So start thinking like the machine has started at exactly 12 o'clock today. So by the end of the 2 o'clock, machine 1, the processing of the first job is over, that job 5. See like that. So by the end of the 6 o'clock, so job machine 1 processed 3 jobs and machine 2 processed only 2 jobs. So for this machine 2 10. So by the end of the 10 hours, machine 1 processed 4 jobs, machine 2 processed 3 jobs. So here again it will start 10 plus 3 13. So by the end of the 13th hour, machine 1 has processed 4 jobs completely and job 3 is processing. From 10 to 15 hours it is processing 5 hours. So but job machine 2 has also processed 4 jobs, but it's waiting for getting the job 3, so it has to be idle here. So 15 to 6 21. So again it has to get idle till 25 25 27. So that's about machine 2. Machine 3 next, in and out time. So third hour we got the job. So 3 plus 7 10. So 10 plus 7 17. 17 plus 6 23. 23 plus 9 32. 32 plus 7 39. 39 plus 8 40. 39 plus 8 47. So for job 3, once the job 2, look at the job 2 out time and go on adding the processing time of job 3. Wherever job 2 is not yet came out, then you have to take wait for that, because everywhere it is always greater than. So job 3 itself is releasing jobs late. So make span time equal to 47 hours. Idle time of machine A or machine 1 M1 equal to 47 minus 25 equal to 22 hours. Idle time of machine 2. Machine 2, is there any idle time? 2 hours is idle time plus initially, and there is 1 hour 5 to 6 here. There is one idle time. Here also one idle time. Here also one idle time. So 2 plus 1 plus 2 plus 4 plus, this is the total idle 47 minus 27. So overall this also 4 8 9 29. Idle time of machine 3 equal to 3 hours initially, then later on it is not at all ideal, 3 hours. So this is a way you need to solve the for more than two machines problem. Next we will solve one gate question. Question number 10, page number 44, ME 2006. So 2 marks question they gave in 2006. The data he has given is jobs PQRSTU. He asked make span time calculation. So M1, M2, 15, 6, 32 processing times, 19, 8, 13, 27, 20, 11, 14, 16, 7. So optimal make span time of the shaft. Calculate optimal make span time of shaft. So here first we need to calculate optimal sequence. Optimal sequence equal to, so to get optimal sequence as our procedure, So how many jobs? 5 jobs. 3, 5. 5 is enough. So once we get the optimal sequence, then machining time calculation we know how to do that. So we don't need to worry about that. So first objective is to get the sequence. Look at the what is where you will get minimum processing time out of all the processing times. 6 is the minimum processing time, which is present in P, job and machine 2. It is in machine 2, so that's why you need to keep last. So P has to keep last. Next list is 7. It is also in machine 2. Keep it again next last. Next you look at the next minimum is 8 is there, which is with machine 1. Keep it first. Next is minimum is 11, which is with machine 1. So next remaining is only one queue. Keep the queue here. No, there are another. Oh, sorry, I'm sorry. Oh, I'm sorry. One second. Just write it again. So what we need to do is we need to take 6 blocks. So first, as a first step, we start with least processing time. We assign that P is there, and then after that least processing time U. Next processing list is 8, or next list is 11 P. Next list, look at the after that 11 there is 13, which is with machine 2. So that's why we need to keep R here. So Q will come here. So sequence we got. Now format the table. Formulate table. R P Q. Okay. One second. So R is again 2 times, right? So it's wrong. Something is wrong, man. So here R is after assigning T, next minimum is 13. R is already assigned, so we don't need to assign that. Next again minimum is 15. P is assigned, so we don't need to assign. Next minimum is 16. U is assigned already, no need to think of that. Next minimum where you will get 19, that is Q, machine 2. So Q will come here. So that's why S will come here. Okay, Q and S. You have to be careful. These calculations, once goes wrong, entire thing goes wrong. So RTS Q U P. Right, you got the sequence. Then check it out. The make span time of machine 1. N is in out. So in initial it is there. Machine, we should have written the processing times. It will be easy. Better write the. So optimal sequence. So machine 1, machine 2 processing time. For R it is 8, machine 2 is 30. For T 11, 14. for Q 32 19. So for S, right? Sorry, for S. Okay, because there is a high chance to do mistake, that's why. For S, 27 20. For Q, 32 19. For U, 16 7. For P, 15 6. This one is 6. So machine 1, in and out time. 0 8 8, it will start. 8 plus 11 19. 19 plus 22 41. 41 to, so 19 plus 27 46. 46 to 32. 46 plus is Q, right? Q has 32. 46 plus 32 is 78. So 78 to 15 is 94. 94 to 6 is 109. There is high chance to do mistake. That's why they have given this question, I think. So next one is 8 will start at 8, and 8 plus 13 21. 21 plus 4 8 14 is 35. 35 plus 20 55. Okay, 35. But here you need to be careful. So if we kept 35 here, it is wrong, because by the time it is but here the job yes is not over on machine 1, so we need to wait. So then 40, sorry, 78. Okay, 46 to 66. 6 next you need to wait again. 78. 78 to 97. 97 to 104. 104. 109 to 125 is the last. So make span time is 125. So it looks like, because the numbers are bit confusing, so you need to be careful in that. So this is the type of questions generally in the forecast, this first production planning and control. They ask mostly questions on forecasting, especially exponential smoothing, and then sequencing, like first come first or shortest processing time, earliest due date problems. Like they ask, number of tardiness jobs, number of early jobs, all these questions. The next thing is this one, machines. So first important is exponential smoothing, next important is sequencing, next important is scheduling. So these three are important topics in this problem. 2 marks question, almost all, so many times will came from this. So better prepare for practice all these problems, at least one or two problems. Try another problems also in your textbooks. then you can be confident about this. Thank you.